3.3, linear and angular velocity, deal with objects that are traveling in a circular path at a constant speed. Okay, so if we think about the tire of a car, which has a higher velocity, the top of the wheel or the highest bolt? So that's going to depend if we're talking angular velocity or linear. So for angular velocity, both of these parts are going to have the same angular velocity. Okay, but if we're talking linear velocity, the top of the wheel is actually going to have to go a farther distance in the same amount of time. Okay, so it's actually traveling at a higher linear velocity. So what do these words mean? So angular velocity is an angular distance over time. Well, how do we measure angular distance? In degrees or radians. Okay, so if we're giving an angular distance, we're going to have degrees or radians over a unit of time. So labeling our units in this section is going to be incredibly important. Linear velocity is a distance over time. So any unit of distance, inches, feet, miles, yards. Okay, so in order to do this, we're going to first need a starting point. So we're always going to start our problem with a number of rotations over an amount of time. Okay, so hopefully that's going to be given to us in the problem. And then we're going to have to use equivalent measurements to change our units. Okay, that is the point of linear and angular velocity here. Your problem starts in one set of units and you want to convert it into whatever the problem is asking for, a different set of units. So some equivalents that we want to take note of. One rotation equals 360 degrees. One rotation also equals 2 pi radians. Think of some other equivalent measurements that you know. Okay. 12 inches is 1 foot. 5,280 feet is 1 mile. 60 seconds is 1 minute. 60 minutes is 1 hour. 24 hours is 1 day. Okay, think of any other equivalents that you know. Okay, now one conversion that you do not know, 1 radian, okay, which is an angular measure, equals 1 radius. So this radius can be any unit of distance. Okay, inches, feet, whatever. So this conversion is actually what's going to allow us to cross between an angular measure into a linear. Okay, so 1 radian equals 1 radius. Probably one of the most important and the least obvious conversions that we're going to have to use. Okay, so if it takes the world 24 hours to make a full rotation, okay, we're going to find the angular velocity in radians per hour. So this is the conversion that I'm trying to end in. All right, so we always want to start in a rotation over a time. So it takes 24 hours to make 1 full rotation. So we have 1 rotation, I use ROT, over 24 hours. Okay, now if you've ever done stoichiometry or dimensional analysis, that's exactly what we're doing here. So we're trying to take 1 rotation and 24 hours and convert it into radians per hour. Well, luckily for us, okay, we're already in hours. So that's 1 unit of measure that I'm already where I need to be. Okay, now I'm going to have to multiply by an equivalent that's going to allow me to cancel out my rotations, to turn my rotations into radians. So how many rotations equal how many radians? That's what I'm trying to ask myself. So one rotation is 2 pi radians. Okay, so I'm going to use that equivalent to multiply by here. Now I want to set this up in such a way that my units are going to cancel. So I'm trying to cancel out rotations. So if rotations is on the top, okay, I'm going to have to put it on the bottom here so that these will cross cancel. Okay, and the top and the bottom of every single fraction needs to be equivalent. So one rotation is 2 pi radians. So now I look at any of the units that I have not crossed off. So I have multiplying across the top, 1 times 2 pi. I have 2 pi radians. And multiplying across the bottom, I have 24 hours. Okay, so radians per hour is the measurement that I was intended to end with. So now I'm just going to reduce what I have here. And I have pi over 12 radians per hour. Okay, and that is my final answer. That's an angular velocity because I'm using an angle measurement of radian. Let's try another one. Okay, so again, talking about the Earth. So one full rotation in 24 hours. Okay, we want to find the linear velocity in miles per hour. Okay, so those are the units I'm trying to convert into. Right, and we need to know another piece of information, that the Earth has a radius of about 4,000 miles. Okay, so I like to do the time first because that's always the easiest. Okay, so I'm in 24 hours here and it's telling me to go miles per hour, so I'm where I need to be. Now, think to yourself, do I know how to get from one rotation into miles? So how many rotations equal a mile? Okay, and if you don't know that conversion, well then that means we're going to have to use 1 radian equals 1 radius. Okay, so if you don't have a conversion for something, you're going to have to take an intermediate step of 1 radian to 1 radius. Now before I can do that, my problem needs to be measured in radians right now. And it's not, it's in rotations. So I'm first going to convert into radians. So 1 rotation is 2 pi radians. Okay, so my rotations cancel. Now that I'm in a radian, I can use 1 radian equals 1 radius. Well, what's the radius of this object? The object is Earth. The radius is 4,000 miles. So 1 radian, placing that on the bottom so that units cross cancel, 1 radian is 4,000 miles. So those are equivalent, 1 radian to 1 radius. And remember, we said this can be any unit of distance. Okay, we happen to be using miles here. So now my radians cancel. Okay, and I'm going to evaluate what unit of measurement am I in right now. I'm in miles. Okay, which is what the problem was asking me to do, miles per hour. Okay, so multiplying across the top and across the bottom, making sure to fully simplify. Okay, and you can leave this in terms of pi. We get 1,000 pi over 3 miles per hour. Okay, miles is a linear measurement, so this is a linear velocity. linear velocity is the more difficult of the two types of problems because you have to remember to apply this 1 radian equals 1 radius. Okay, thinking about an analog clock. Okay, an analog clock is one with the face and the arms. Okay, so if it takes the minute hand 1 hour to make a full rotation. So remember, we always start rotation over time. So 1 rotation in 1 hour. Okay, and the problem is asking us to do degrees per minute. All right. So I said I like to do the time first. It doesn't matter what order you go in. The time is always a little bit easier. So we're going from hours into minutes. So in order to get hours to cancel, we're going to have to put it on top. So 1 hour equals how many minutes? Can I get there all in one step? Yeah, I know that 1 hour is 60 minutes. So those are canceled. So I'm now in minutes, which is where I need to be. Now I need to go from 1 rotation into degrees. So do I have a conversion for that? From rotations to degrees. 1 rotation equals how many degrees? I have that. Okay, 1 rotation is 360 degrees. In order to get rotations to cancel, has to be on the bottom. Okay, so now I'm left in degrees per minute. So multiply across the top and across the bottom, and then simplify. I get 6 degrees per minute. Okay, you must label your units. All right, again with the clock hands. So the minute hand takes 1 hour to make a full rotation. So 1 rotation over 1 hour. Okay? They're saying given that the minute hand is 4 inches long. So think about this clock down here on the bottom. This is the minute hand. If they're telling you that this is 4 inches long, what does that represent on the clock? Okay, that minute hand of 4 inches long represents the radius. Find the linear velocity of the minute hand in inches per minute. Anytime that you see the word linear velocity, you want to automatically know you're going to have to use 1 radian equals 1 radius. Why else would they be giving you this extra information in the problem to tell you that the minute hand is 4 inches long? So, inches per minute. I'm in rotations per hour. Well, it feels easier for me to go hours into minutes again. So 1 hour is 60 minutes. Again, positioning hours on the top so that my units will cross cancel. Okay, circling my measurement here because minutes is what I need to end with. Now, rotations 2 inches. Remember that bridge between angular and linear is 1 radian equals 1 radius. So I have to first get my problem into a radian. So how many rotations equal how many radians? 1 rotation is 2 pi radians. Only once you are in radians can we use this bridge conversion. Okay, this angular to linear. So 1 radian equals the radius here. The radius is 4 inches. Okay, you have to always make sure that your units are matching up. So I wouldn't go on to the next step until you can make sure that you can cancel your units. So I wouldn't be able to use 4 inches over 1 radian from my original problem, which started as a rotation, because rotations and radians would not cancel. I am now in inches, which is where the problem is asking me to be. I'm going to multiply across the top and across the bottom and fully simplify. Leave it in terms of pi. 2 pi over 15 inches per minute. It takes it takes the second hand 1 minute to make a full rotation. Alright, so same clock, different measurement. So 1 rotation in 1 minute. Find the angular velocity of the second hand in degrees per minute. Well, I'm already there on the time. How do I get from degrees to rotations? 1 rotation equals 360 degrees. Okay, make sure that those units cancel. Make sure you're canceling them out on your paper. So now we're left in degrees. So 360 degrees per minute is my angular velocity here. Okay. So it takes the minute hand 1 hour to make a full rotation. 1 rotation in 1 hour. Given that the second hand is 6 inches long, well, why would they be telling me that unless I was going to have to use it? So 6 inches long, 6 inches here, is the radius. Find the linear velocity of the minute hand in inches per minute. Alright, so I need to convert hours into minutes. I'm going to do that first. That's easy. 1 hour is 60 minutes. Okay, cancel, cancel. We're in minutes now. Alright, now I need to get into inches. So how many rotations equals how many inches? We don't know. Remember, whenever we don't know, we're going to write 1 radian equals radius. Okay, so in order to use this conversion, our problem has to first be in a radian. So 2 pi radian over 1 rotation. This is the step that's most forgotten. Okay, to convert into a radian before you use 1 radian equals 1 radius. You can't do that if the problem is in a rotation. So now that it's a radian, 1 radian equals the radius. In this case, 6 inches. Okay, inches per minute is where I'm supposed to be. So check that your units cancel. And you're left with only inches per minute. Okay, multiply across the top and across the bottom, fully simplify, get pi over 5 inches per minute. Okay, our last example here. So Corey's truck has wheels that are 36 inches in diameter. If the wheels are rotating at 630 RPM, that's revolutions per minute, find the truck's speed in miles per hour. Okay, so this is revolutions per minute. So revolutions are the same thing as rotations. Alright, so we start with rotations over time. So 630 revolutions, REV, per minute. Over 1 minute. All right, we want to go in miles per hour. So let's do the time first. Okay, minutes to hours. 60 minutes on top. Over 1 hour so that these units cancel. Okay, circling hours, that's where I'm supposed to end. Now revolutions to miles. So 1 revolution equals how many miles? We have no idea. If we have no idea, 1 radian equals the radius. Okay, in order to use that, we have to first convert into a radian. So 1 revolution, remembering it's the same thing as a rotation, 2 pi radians. Okay, once the problem is in a radian, 1 radian equals, what's the radius here? 36-inch diameter. Don't just take the value and run. Think about what they're actually telling you, because the radius is 18 inches. I'm not done yet. I'm in inches and I need to go to miles. What would be an intermediate step here? Inches to feet. Okay, so 1 foot equals 12 inches. So make sure that the units cancel. And then finally, 5,280 feet is 1 mile. Okay, so I have arrived at miles per hour. Now, this is a little bit of a longer problem. Some of these numbers are much bigger, so if you want to simplify or cross-cancel a little bit before you multiply, you can do that. Okay, you can also just multiply everything across the top and everything across the bottom, and you should be able to plug it into your calculator to simplify. Okay, and we end in miles per hour.